Alright, so let's go ahead and look at number 3. So I'm going to start out by writing the transformation. So it's right here, it's saying, so it's a reflection across the line x equals 1, and then composed translation of 2 units to the right and 2 units up, and then composed rotation of negative 90 degrees with the, remember that the O here just means that the center of rotation is the origin. That's not really relevant here, it just means that we can use the formulas that are on the pink sheet, the little post-it note, post-it note. So this is just center of rotation. Again, it's just there for the notation, but it's not relevant, because this just again tells us that we can use those formulas and we don't use it ever again. It's just telling us we can use them, that's all. Alright, so first thing that I'm going to mention here is this negative 90 degrees. When you see negative 90 degrees, let me mention what this means in math. Rotations are usually going to be counterclockwise. And by the way, when you take pre-calculus and calculus, your angles are going to be counterclockwise as well. So it's just a convention that we move in a counterclockwise direction. Now, when you have negative degrees, that just means clockwise. So if you had your shape right here, and you're going to move it negative 90 degrees clockwise, that means that the shape would end up over here. So it would be going basically 90 degrees in this direction as opposed to counterclockwise. The formulas that are in the pink post-it note indicate counterclockwise rotations. So all we need to do is we need to realize that moving 90 degrees clockwise is equivalent to moving 270 degrees counterclockwise. So in terms of our little formulas, we're going to be using the one for a 270 degree rotation counterclockwise, and that one, if you remember, you look at your formula chart, is the one that has y comma negative x. But I do want you to practice, looking at your formula chart to see it, right? So that's important as well. Just make sure that you can locate all of the appropriate formula. Okay. Let's see. Alright. I was trying to see if I had the problem. I didn't know where I printed it, so I have it over here. Alright. So now we're going to go ahead and apply our transformations to the points, and I have them written over here. It was h, and that's 2, 2. Okay. And then I'm going to write the next one underneath. It's I, that's negative 2, 2. J, that is negative 2, negative 2. And K is 2, negative 2. 2, negative 2. Okay. Alright. So we're going to go ahead and apply our first transformation. And remember, when we're dealing with compositions, we read them from right to left, right? So we start with the one on the right, and then we move leftward. So I'm going to go ahead and start with our first one, which is the counterclockwise rotation. So I'm going to go ahead and write it over here. Rotation, negative 90, origin there. And what's our little formula that we use? Well, it's xy, arrow, and then y comma negative x. So we're just going to be applying this formula to all of the points. So we're going to flip them. So this is saying h is 2, 2. So now it turns into 2 comma negative 2. Okay, so all that happened was the y jumped to the front, the x jumped to the other side, the y value slot, and we just changed its sign. Now we're going to go ahead and do this one. So I prime, again following our little formula. So the y value hops to the front and we don't change the sign. The x value hops to the back and we change the sign. Okay, so that's all I did here. Now for the j, I'm going to put here j prime. Again, same thing. The y value hops to the front. We don't change the sign. The x value hops to the y slot, and we change the sign, so you get that. And then finally, k prime. Same process again, so negative 2 comma 2. Okay. So we have just performed our rotation of 270 degrees counterclockwise or 90 degrees clockwise. I'm not going to graph all the different, I'm not going to graph each transformation. I'm just going to do the first one. Not the first transformation, but the pre-image, right, the original picture, and then just the final after you compose. Right after the composite transformation, it's the final image. Okay, so let me go ahead and do the next one. That one was a translation of 2 units to the right and 2 units up. So I'm going to write that here. So translation, just to be systematic. And I'll put it over here also. Okay. So now we get the h prime. And this is, let me just copy this on this side. H prime, and then you have I prime is 2 comma 2. J prime, 2 comma 2, and then k prime is negative 2 comma 2. Alright. So we're just going to add 2 to the x value and then add 2 to the y value. So I'll go ahead and write it over here, h double prime. 2 plus 2 is 4. Negative 2 plus 2 is 0. So it goes to 4 comma 0. And then I prime, that becomes 4 comma 4. Remember, we're just adding 2 to the x and 2 to the y. J double prime is 0 comma 4. K double prime is 0 comma 4. Okay. Now the next one's tricky. So I think the best way of doing the next transformation is to actually graph the points. Excuse me, I was just getting water. So we're going to actually graph the points to do the last transformation. So I'm going to go ahead and plot these that are right here on my grid. The first one is h double prime. That one's at 4, 0. So 1, 2, 3, 4, 0. So it's right there. That's h double prime. And then we have I double prime, which is at 4, 4. So 1, 2, 3, 4, 1, 2, 3. That's over here. I double prime. And then we have J double prime, which is at 0, 4. And that's our J double prime. And then let me check something in my work, because according to this I just noticed that K double prime and J double prime are in the same spot, which is not correct. Hold on, I think there is a mistake here real quick, hang on. Or what is it? So here we flipped them, so this is -2, -2. Oh yeah, I forgot to put the -2 there. Yeah, sorry. Yeah, so when I did the rotation here, the -2 hops to the front, this hops to the back, but we have to take the negative of it. So this is really should be -2, -2, which means that K prime over here is -2, which means that this is actually 0. Okay. So K double prime is at the origin, right? 0, 0. K double prime. Okay. Now we have to be very careful because what is it that we're doing? Well, for this one, we're reflecting across the line x equals 1. So first, let me go ahead and draw that, but I'm going to use a different color. I'll use purple, just so that we can see what's going on here. So the line x equals 1, if we remember from algebra, is a vertical line, and I'll do it dashed, kind of a dashed vertical line, that crosses the x-axis at 1. So I'll do this. Alright, so this is a line x equals 1. Now, what we need to do when we're doing a reflection is the stuff that's on the right side is going to end up on the left side, and the stuff that's on the left side is going to end up on the right side. Question is, how do we do that? Well, we need to count the spaces from the point to the line that we're reflecting across. So let's go ahead and do that. Now remember that our I prime and our H prime on the x-axis are both at 4, and here we're just looking at the x-axis. So how many units is this from the vertical line? Well, it's 1, 2, 3. So it's 3 away. We just count the little spaces, right? 1, 2, 3. Now all we need to do is go 3 on the other side of that line. 1, 2, 3, and then we put our point. Okay, and then this is where the triple prime is at, which is the final, this is our final image, right? And then the same thing happens with H double prime, so we have to go, it's 3 spaces, so now 3 on the other side. So 1, 2, 3. So it's right here. Okay, and let me go ahead and write the coordinates here so that it makes sense. So now, when we went 3 this way, we ended up at -2 for the x-axis, and the y-axis will stay the same here. And then for our H triple prime, we got -2, 0. Okay? Alright. Now let's go ahead and transform J and K. Now this time, J and K are on the left side of that line, so that means they're going to end up on the right side. So J is 1 unit away from the line of reflection, which means it has to be 1 unit on the right side of the line, right? So here we have J triple prime, and this one is going to be at, on the x-axis, this is at 2, comma, and then for the y it stays the same, which is 4, and the same thing is going to happen with K. So it's 1 unit away, so then we flip it 1 unit over here. And then we have our, where is it? Yeah, it's right here. So this is K, and then we'll put triple prime. And that would be at, what did we get here right now? So 0, 0, so then it's at 2, comma, 0. So then that final image, this kind of this little quadrilateral here. I'll just connect the dots, yeah. So this is our final, that quadrilateral is our final image. Alright. So here instead of graphing the original pre-image, I'll let you do that, but I just wanted to see, that was I think the trickiest part, is reflecting it across the line x equals 1. So kind of just want to make sure that you're understanding that part. What I'm going to do is I'm going to break this into 2 videos. Or you know what, I can probably fit it in one video, yeah. So let me do the last 2 questions. Yeah, it's actually better if I do it all in one video. So, let's see, because these questions are actually very short. Okay. Let's first do this one. Sorry for going backwards here. I'm going to start with number 8. Okay. So we need to use coordinate notation to show this transformation. So the first thing that we need to do is we need to obviously find what the pre-image is, right? We need to know what the notation is telling us, right? So on the left side of the arrow is a pre-image, and on the right side is the image. You don't have to write this, I'm just putting it here just for explanation. Okay. So that means that in terms of our arrow notation, we're going to have points from our preimage, so A, B, and C, and then we're going to have to draw these arrows to get K, L, and J. So I'm just kind of writing the outline here, K, L, and J. So this is the outline. And then we're going to figure out how to plug in the numbers. Well, for A, for the left side it's easy, right? We just have to find the numbers here from the picture. So we got, let's see, is it negative 9, 8? Yeah. So our first one is negative 9 and 8. Then our second one, B, is at what? That's at negative 4. Negative 4, 7. And then our C is at negative 7, positive 1. Okay. Now we have no idea what this transformation is. We have to figure it out from the picture. We need to see some kind of relationship between the letter A, the letter J, the letter A and the letter K. Where's K? It's kind of blurry here. I'm just looking at the wrong one. Yeah. The letter A and the letter K, just like here. And then the letter B and the letter L, so that's here, and then L is over here. And then the letter C and the letter J. So what I'm thinking here when I'm looking at this, if you think of our transformations, this seems like we're rotating it. And what I mean by rotate, I mean we're taking this picture and we're rotating it to get it on this side. So we're going from quadrant 2 to quadrant 4. So to me this seems like a rotation of 180 degrees, but we're going to check that. Once again, why did I say 180 degree rotation? Because it's skipping this quadrant and it's landing over here. Right, so it's going from here, so it skips this one, lands over here. So that's what's suggesting a 180 degree rotation. Of course we need to check that. And what we need to do is remember our formula for the rotation of 180 degrees. And that formula was this: x comma y arrow negative x comma negative y. Let's go ahead and check if this is true. Now, using our formula, we can see what this would produce on the right side. So we would just swap the signs for each of these. So now A would be transformed to K, which would end up being 9 comma negative 8. B would be 4 comma negative 7. And C would be, C would be transformed to J, which is 7 comma negative 1. And again, I'm just changing the signs using our formula. Now we're going to confirm that that's what happens. So where's K in our picture here? K is down here. And if you look carefully, what are the coordinates of K? Aha! Coordinates of K are 9 and negative 8. So that checks out. So good, that one worked. How about B? So that one goes to L. So where's L over here? Let's see, what are the coordinates of L? Interesting. They are 4 and negative 7. Ah, look, 4 and negative 7. Check mark. Now let's look at C, which transforms to J. And J down here in the picture is at 7 comma negative 1. And yes, indeed, we got 7 comma negative 1. So what that tells us is that our transformation here really is a rotation of 180 degrees. Alright? So you would write this whole thing as your answer. Okay. Now we're going to go ahead and do number 7. And I'm going to start it off with notation here. So A, parentheses, kind of the little skeleton part, and then B, and then C, and then A, B, C, G. That's interesting. I wonder why they skipped D. Alright. and then arrow, 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 and then K on this side, and then H, I, and then J. Okay, so let's go ahead and fill in the numbers for the left side, our pre-image. Notice that our pre-image is smaller. Our pre-image is a little one right here, right? Notice it's smaller than the image. What does that suggest? Well, it tells us that this must be a dilation with the scale factor greater than 1 because it got larger. So let's go ahead and figure out what that scale factor is. Let me go ahead and write the points first. So A is -2, -3. B is 0, 5. C is 6, 0. And G is 1, -3. Okay. So what I'm going to do here for side work is make a little algebra equation. The x value for A is -2. And if this is a dilation, then we need to multiply it by something. So I'll put times x to get -3. Okay? So we need to solve for that. So going back to our pre-algebra skills, how do we do that? Well, this is multiply. So we need to do the opposite, which is division. So we divide by -2. This cancels, and we're left with x equals 3/2, which is 1.5. Alright, so that's how you go from -2 to -3. Let's check if the same applies from -3 to -4.5. So we can check that again. So let's set up our little equation. Of course, this is just a check. You don't have to do this part, but -3 times x equals -4.5. Again, we divide, x equals, and we get the same result, 1.5. So again, this tells us that we're using the scale factor of 1.5. So this is really a dilation. Or I could say dilation with scale factor of 1.5. And our formula for that would look like this. X comma y arrow 1.5 times x comma 1.5 times y. So we have to multiply both the x and the y by 1.5 to get the image for each point. So let's go ahead and do that. And this one would be -2. So let's actually write it like that. Times or multiplied by 1.5 and then -3 multiplied by 1.5. So we're actually going to write the multiplication for each point. And then we could put like equals and then k and then write the final answer, which is over here is -3 comma -4.5. So I'm going to put these little equal signs here. And then let's look at h. So we're putting 0 times multiplied by 1.5 and then 5 multiplied by 1.5. And then for I it's 6 multiplied by 1.5, 0 multiplied by 1.5, 1 multiplied by 1.5, and -3 multiplied by 1.5. And then I'm going to put a little equals just to kind of write the final result here. So that's 0. And then the second one here is going to be 7.5. And then for I, we get 9, 0, and then finally here j is going to be 1.5, comma, negative 4.5. Alright, so that's what you want to write down to show your work and the final answer here. So that's how you do that problem, and we are done for this video.